So dear students, parents and colleagues, good afternoon. My name is Angela Luca and I'm Kültür2000 International Baccalaureate Diploma Program Coordinator. I'm very pleased to welcome you all today to Culture Nobel Talks live streaming. In times of social distancing and lockdowns and travel restrictions, it is our desire as educators to tailor unique learning experiences for our students and to encourage them to keep learning and searching for knowledge. In line with these principles, today we are honored by the presence of Professor Didier Queloz, a Swiss astronomer and Nobel laureate. Good afternoon, sir, and welcome to Nobel Talks live streaming.
Good morning.
How do you do?
I'm fine. It's a pleasure to be here. Sorry for last week, but this one it will work.
Yes, it is working. Thank you very much for joining us today. So I'm a diploma program coordinator, an educational program which was born in Geneva, which happens to be your hometown.
Yeah, that's my background, you see.
Yes. It's a very beautiful city. So I would like to spend a few words about your prize motivation, if you don't mind. Professor Didier Queloz was awarded the 2019 Nobel Prize for Physics by the Royal Swedish Academy of Sciences for his discovery with the Swiss astronomer Michel Maillot of the first known extrasolar planet orbiting a sun-like star. And Professor Queloz and Professor Maillot received one half of the prize. The other half was awarded to Canadian-born physicist James Peebles. So first of all, sir, I wish to heartily congratulate you for achieving a Nobel Prize in Physics. And I have a little curiosity. I read that when you were a child, you used to break stuff apart to understand how they worked. And may I ask you, what motivated you to become a scientist?
Yeah, well, that's true. I think I was extremely curious, and I am very curious. So certainly one of the key, driver or reason why some of us are becoming scientists is to express this strong feeling about the curiosity. You really want to know, and I guess that's what I am. From early on, I was very curious, essentially about everything. It's not only about physics; it's about everything. I'm extremely curious. In a way, this is something fascinating because when you look at a child, they are extremely curious as well. That's a process to learn. The learning process is essentially stimulated by this intense curiosity. And for some reason, people tend to lose it when they become adults, which I think it's a bit sad. But some others, they always keep this kind of childhood energy and this curiosity. And I guess this is why I become a scientist. So physics, it's a bit, I think I went to physics because I was easy with, let's say, rational and mathematical and logical thinking. So that was something I was easy with. I never had difficulty in mathematics. I can just read the mathematics pretty easily. And the mathematics is one of the tools in physics. Like if you know to draw, some people gifted to draw, they can draw anything. And then later on, they are working in the some kind of artistic industry because they are gifted. So it's easy for them. So that's what I was. But then this mixed up with the curiosity, and I realized that physics was the most generic kind of study I could do, it was a trick maybe I did to try to postpone as much as I could the decision what to do really in my life. So I said, oh, let's study physics. It's good. And then I went in my physics study and physics degrees. I was reading a lot of stuff and not only about astrophysics, but I realized astrophysics was really a cool topic. There are really big questions in astrophysics. It's great physics. And it's also a kind of science that you could do kind of outside. And you may know that we have wonderful observatories on very remote areas and some tip of volcanoes or high plateau of Atacama Desert in Chile or Canarian Islands, and on and on and on. So these places are very, very special. And I like the night sky. I like it. I always feel at ease. So all this together, I went into physics, and then when I started physics, I get even more curious, and that's how I ended up doing a PhD in science.
Okay, that's a very interesting story. Thank you very much for your reply. If I may ask another thing, what was your initial reaction when you learned that you won the Nobel Prize?
Oh, I was really shocked. This is the biggest possible prize you can get in physics, and I know that this discovery of the planet was a major event, and in somewhat an historical event, the first planet. But there are so many work, there are so many great physicists, there are so many people more clever than me. Then as sudden, then you say, oh wow, so this is me. And I was really shocked. I was not expected it, or certainly not expected it to get it kind of young, because I'm still kind of young for the Nobel Prize standard. While most of the people, they do the main discovery when they're very young, and they have to wait a long time. No, it was a real shock. It was a real shock. And then I feel a kind of weight, because it's also responsibility, because you become a kind of a flag. You are an example. And everybody is looking at you, and they ask, oh, what should I do to do like you? And that's why I usually don't have a clear answer. I just say, well, I don't know. I never thought about getting a Nobel Prize. I just had fun, and I was curious, and I was working to try to solve mysteries and problems, and that's how at the end, one of my work led to the Nobel Prize. That's how it worked.
Thank you very much for sharing with us. After attending the 2017 Nobel Prize Award ceremony in Stockholm and interviewing 2017 Chemistry Nobel Prize Professor Joachim Frank, Kültür2000 College high school students, they have made some research, and they have prepared some interesting questions about your discovery, and would appreciate the opportunity to listen to your answers. Okay?
Sure.
And we're going to listen to the questions one by one. And we're going to start now with question number 1, prepared by our student, Parsa.
Hi, I'm Parsa. I'm a 10th grader at Kültür Science High School. How do you interpret the awarding of the Nobel Science Prize to a space research? Thank you.
Thank you. I missed the last end. I mean, how should I interpret what? Could you just repeat the question?
The awarding of the Nobel Prize to space research.
Oh, space research. Oh, sorry. Yeah. Well, I don't think the prize was awarded for specific space research or astrophysics research. It was awarded for physics result. Now, astrophysics is part of physics, and there is a good reason for that. We used to say that the universe is the biggest physics lab you can have and play with. You can meet in the universe the biggest, the higher pressure, the hottest, the smallest, the farther away. You can even go back in time. So you cannot do that in a lab, in an experimental setup. So exploring our universe is exploring the physics where we are. So we are one of the examples of many that we find into a universe. So it's interesting to see that in the last 5 years, there has been 3 times Nobel Prize given to topic which is related to astrophysics, which is physics of the universe. And that's not by mistake. It's because the universe is a fantastic lab. In addition to that, we have seen in the last 20 years an immense progress in technology. We have now far more sensitive detector, and we can look and listen at the universe in a much better way that we could be doing that 50 years ago. So we used to qualify this time as the golden age of astrophysics, where a lot of people are trying to use space, and even people studying the small particle now, and nuclear physicists or particle physicists, they are using big antenna because they are listening these particles. They're trying to get this particle from space, because space will be the more powerful accelerator you can build. So I know we have heard about the discovery of the gravitational waves. The Nobel Prize was given last year, and that's fundamental physics. This is the only lab when you can produce this is when you bring 2 black holes or very dense dense object like a neutron star together collapsing, that's the only way to produce this kind of waves. You cannot do that in a lab. So again, I think physics is at its best when you look at the universe.
Exactly. Yeah, thank you very much for this reply. We're ready now to listen to question number 2, prepared by Can Jedi. Here we go.
Hello, my name is Can Jedi Sayışman. I'm a student from Kültür High School. I'm a 10th grade student. Do you think your studies may have taken a step to discover extraterrestrial life, if any? Thank you for your attention.
Question, right?
Yeah, it's a very good question. You know, this is interesting because the day after we detected the first exoplanet, 51 Peg, people started to talk about extraterrestrial life and life in the universe. And I was surprised, and we were both surprised with Michel 25 years ago, because the planet that we detected was really impossible for life. It was a Jupiter roasted, I mean really physically roasted, because it was so close, so hot. That's why we call them hot Jupiter. But what is behind actually is the prospect, is when you start detecting planets on other stars, well, there is a point when you have to ask the questions, what's going on these planets? And definitely finding planet on other stars has been an immense stimulation for the field and the question of life in the universe. But there is a limit to what we can do here in this program. Is the stars are so far away, so we will never be able to really practically go back and bring stuff back. Certainly not in the 1,000 year. But we have a lot of planets in the solar system that would be extremely interesting to look for what you call extraterrestrial life. There is Mars, it's obvious, the Martians, but there is also Venus. Venus is interesting. Who knows? I mean, Venus some time ago was, we think, like the Earth, a blue planet, and because of the plate tectonics that stopped recycling the CO2, I think the Venus atmosphere changed and evolved into this fully greenhouse effect. There's also some satellites of giant planets, Europa and Enceladus, that are very, very interesting because we know there are water there and we know there's hot water there. So there are certainly fascinating field of research about looking about life. Detecting plenty of planets is a fantastic stimulation, and we will certainly look at that. We have plenty of ideas, and at least what the exoplanet field has done is to make this field of looking for life in the universe something which is almost a normal field of research. 20, 30 years ago, people that would look like this or was kind of seen as a kind of a weirdos or something with weird ideas. Not anymore today, and there are a lot of people working on that. There are a lot of chemistry work, fantastic chemistry work on the origin of life. There's a little bit of revolution going on right now, and there are serious attempts to look at the atmosphere of planet, trying to find first water. Do we have water on other atmosphere? And then many other molecules that could tell you that something interesting like life is going on this planet. So yes, we have changed the field. Yes, we have stimulated the question of life in the universe.
Thank you very much. We're ready now to listen to question number 3, prepared by our student, Berna.
Hello, I'm Berna Akpınar and I'm a 10th grade student from Kültür Koleji. A short time period ago, I participated in a physics project which is related to exoplanets, and we tried to find some new exoplanets by the help of different methods, such as transmission method. So I want to improve myself in this area. So would you give some advice to me and to the students who are interested in cosmology? Thank you.
Well,
that's another good question.
It's a very good question. I have many times I had this question, so now I have even more of that kind of question. So my answer is always the same. I think, I mean, follow your dreams, follow what you really want to do. You have only one silver bullet for life, so let's make use of the life the best you think and for which you can do. If you really want to do science, I mean, never give up. It will be difficult. It's not an easy topic. There is way more easy life than doing in science, but it's extremely rewarding. and it will give you a lot of positive energy. It's always possible to do something. It's not always possible to do it maybe the way you would like to do it or at the time you would like to do it, but eventually it will work. So don't give up. Keep your positive energy, keep your enthusiasm, keep your curiosity. I was mentioning curiosity early on, alive. I think this is recipe for having an healthy and positive life. Continue to do what you're doing. It's great. I'm glad you have been to do that. Don't be afraid to travel if you can. Don't be afraid to meet people and to try maybe something a bit different than what you have thought. Sometimes doing a little bit different things helps to see the world and to see what you're doing with a bit of different perspective, which in science is essential. It gives you these stimulations, these kind of intellectual stimulations that we all need to explore the unknowns. So congratulations to do that, and please keep doing the same, and good luck for you.
Thank you so much. And now we have question number 4 prepared by our students, Irmak.
Hello, my name is Irmak Şahin and I'm a student at 10th grade. We have a magazine called Future Culture published by our schools. And we have been working on the future designs, and I want to ask you a question based on this. So, what kind of studies do you plan to do in the future, and how do you see the world of the future? Thank you.
Ooh, this is a very big question. So, well, I can talk what I'm doing right now. So, I've been a bit obsessed by your situation we are in. We have not found what we call an Earth analog. So it means a planet like the Earth within an orbit like the Earth. So this is something I would really like to achieve with my lifetime. I have set up an international collaboration, so we're building a new kind of equipment to that, to operate in a very, let's say, obsessive way over 10 years on a restricted set of stars, trying to find whether there are these kind of planets. And we really want to explore the nearby stars and to find out where are the Earth analogs. So that's one of my program. The other side of my program is trying to develop a bit more intensive collaborations between astrophysics and molecular biology. There are people studying the origin of life. They are doing very interesting experiments in the lab. I'm trying to bring them out of the lab, and because life is not done in the lab, life is done in the dirt on a planet or in the ocean of a planet. So we are trying to work more and more together, combining molecular biology, geophysics, and atmospheric physics, and then astrophysics together, trying to build up a kind of a new field of research that we call life in the universe. So this is one of my very background activity. I'm trying to help to set it up. It means going to meetings, setting up meetings, and trying to encourage young people to get into this field with mixed background. That's really the essence here, promoting the idea that you are a chemist, but do you understand what the astrophysicists are doing? And if you're an astrophysicist, can you read a molecular chemistry diagram? So it's all about this kind of cross-disciplines idea I'm trying to promote. And I'm spending also some time, and that's the reason why I'm with you right now, trying to promote the future of the field. And the future is you, is the young generation. So anything I can, the students, exactly. This is the students. So I'm trying to do all what I can to motivate people to go into science if they want to do so, and to tell them this is great, and helping them what I can and giving them advice. So this is essentially the core of my activity.
Thank you very much. And now we're ready to listen to question number 5.
Hello, Professor Queloz. My name is Zeynep Öztürk. I'm currently a 10th grader in Kültür2000 Science High School. I have a question for you. For a few minutes, let's consider that time travel is possible, and you've been given an opportunity to travel back in time to a period that you can choose. But you only got one chance. Which scientist or physicist would you like to meet and study with, and why? Thank you.
Interesting question for a physicist. Time travel. Well, Yeah, it looks like a dream because time travel, I'm afraid this is something that will not be possible. I'm pretty sure there's a lot of issues like crossing the speed of light. There is a related questions up into this, which is about how I see my research in time. I mean, in the past and in the future. And there is something which is, to me, essential really to convey here is science is something done over a long time. So my work is based on the work of previous people, and I can go back to Newton if I want. I can even go back to Galilei before. So all the science is kind of a big house when everybody is bringing bits of the house, or a pyramid if you want to see. It's not really a pyramid. Pyramid you get a top. Science has no top. It's more a Babel tower that never stops. And that's how I see science. So any time is essential. I don't think I want to change my time because my time is now, and I always be living in the time now. I never look really formally in the past, but I've been using the past to build up the future. So I think all scientists, we should be in depth of all the previous work being done. Any kind of work. It can be a small piece of work. It can be a big one. We don't all need to be a Newton and Einstein to bring something interesting in science. We're all using a lot of global knowledge being built up by many people. Some people are well known because they are doing big contributions, but we're all doing something, and that's what I like very much. This feeling that I'm part of an history continuity here, where my time is now. This is what I'm doing now. I'm using the past, and hopefully will provide something useful for the future generation of scientists that will be dealing with other problems, other mysteries in the future, but still be using what we have been doing today.
Okay, thank you for your reply. And then our last questions, question number 6.
Hello, I'm Selendiri. I'm an IBDP Year 2 student at Kültür2000 College. The question I would like to ask is, what has been the most surprising or appealing thing about astronomy for you since you first got interested in and started to learn about it? Thank you.
Oh, this is a difficult question. Always the most interesting. Well, I'm afraid I am like a Christmas tree. I'm interested by too many things to really focus on only one. That's my problem. Sometimes I get too curious and I get driven away. But there are a couple of there are a couple of elements in my research work, in my work, that I really like very much. The first one is when you build a project, you're not alone. There's really a lot of people, and it's always nice to work in a good set of group of people that are working within the same kind of goal, trying to achieve something extraordinary. It can be building a new kind of instrument. It can be trying to find a mysterious signal somewhere and trying to make sense to that. And this idea that we're not alone, but there are really people around this kind of group work is very interesting. And even if you kind of compete with other groups, we still like old friends, because when we meet, we exchange ideas, and at the end, we all trying to achieve the same goal. We're trying to make progress into the human knowledge. So this, I like it very much, this feeling of community of science that goes back also what I said about the past. There's something else also what I love very much is when you can stimulate and promote new idea, and the related element is the teaching. So when you realize that you had students, and these students right now are becoming professors, are doing their own way, and they're doing extremely good and in somewhat better than you. So this feeling that you have managed to connect what you're doing with other work that will come in the future. So you had a task which is extremely rewarding. It's a bit like, I mean, when you have child, you see your child walking and going to school, and you're very proud of that. So I find this continuum of work extremely rewarding, and the teaching aspect. And I must say that the global work I'm doing, this kind of intellectual perspective, trying to ask questions and trying to solve questions, is extremely stimulating. I'm not only questioning my science, I'm interested about very different other topics, and and I think it maintains you just alive and very sharp. You never give up. You're always trying to think. You're always trying to see what's behind. You're trying to ask questions about anything. And I think this kind of educated way of working, when you never accept anything, is the future, hopefully, of the society. We have to see the world in trying to not only accept it, but also trying to see it with the possible ways to make it evolving and changing, and making that with the idea that it's for the good of everybody, and trying to increase the level of the quality of living in the whole human society. So all this is something that I really have encountered in my life as a scientist, and I really like very much. I feel very fortunate. Look, I mean, it's still amazed. I mean, I get paid to do something that I just like very much. So
yes, that's great.
So it's I feel really lucky.
That's great. When you have passion for the work that you do, it's really great.
Yeah.
It's really great. Yeah. Professor Queloz, in the name of Istanbul Cultural Educational Institutions, I sincerely thank you again for joining us at Culture Nobel Talks. It was an honor to have you in attendance today. And I would also like to thank our students and the other attendees. I hope that you found this event both interesting and informative, and I'll see you very soon. Sir, thank you again. Thank you very much.
Thank you very much, and good luck to all the students for this kind of difficult end of year. I'm aware that it's not easy to be a student right now, but you're the future, so do good. Good luck to all of you. Thank you very much.
Thank you again. Thank you again for joining us.